Hello students, welcome back to Tuition Masters, and today we are here with atoms and molecules as well as structure of atom. Today we are going to discuss some very important questions of these two chapters from grade 9 CBSE. So yes, we are going to do some subjective questions along with a case study of both the chapters. So firstly, let's start with atoms and molecules. So our first question is, define the atomicity of a molecule, atomicity of a molecule of an element. Now, I will in this playlist I will even attach atom, molecule, structure of atom, these two videos. I will keep it so that you all can access the theory part as well, which I had made one shot videos I had already made on atoms and molecules as well as structure of atom, so you all can refer to them as well. Today we're just gonna solve some questions. So first thing is the atomicity of a molecule. Atomicity means that what this the number of atoms. So number of atoms in any element is known as the atomicity. In one molecule, how many atoms are present, that is called the atomicity. Now there are like monoatomic, there are various atomicity as well, like monoatomic, diatomic, then triatomic, polyatomic, right? There are many, right? So these are, that is the atomicity. So in simple words, the number of atoms present in one molecule of an element is called its atomicity. Now, next question is, calculate the formula unit masses of ZNO, Na2O, K2CO3. Given that, now this is a very good advantage that we have all the atomic masses given. So it becomes very easy to calculate. So Zn we have 65 units, Na 23, K 39, C 12 and O 16. But still, the commonly coming elements, you should remember their atomic masses at some extent. Maybe in the exam they can or they may not give you the atomic masses, so you should remember like carbon, oxygen, nitrogen, then zinc, all of this you should remember the atomic masses, as they're very commonly occurring elements which they ask in the questions. So you should remember their formula unit masses. So let's solve it. First we have, let's do one by one. First is ZNO. All right, now for ZNO, what will be the atomic mass? Zn plus O. Now what is Zn? Zinc is 65 plus oxygen is 16. So 65 plus 16 is equals to how much? It is equals to 81. So for ZNO it is 81 units. Correct? Now similarly, second one we have Na2O. Now Na2O. So this means that I will multiply 2 by the unit mass of Na, that is 23, correct? And then I will add it to oxygen, which is 16, correct? So what will we get? 23 into 2 first we will do, right? So 23 into 2 will give us 46, and 46 plus 16 gives us 62. So therefore it is 62 units, correct? Now the third one is K2 CO3. K2CO3. Now again K2. K is 39. So 2 into 39, correct? Plus carbon is 12, plus oxygen, it's O3. So we will take 3 times of unit mass. So this will be a formula. Now again do the multiplication. First one, 39 into 2, 3, it will give us 78, correct? 78 then plus 12 gives us 90. Okay, next is 16 into 3 gives us 48, and 48 plus 90 gives us 138. So K2CO3 is 138 units. So these are our three answers. Alright, here is your entire solution. Now next thing, calculate the mass of 1.12 sorry 1.12 moles of sulfur trioxide molecules. Now, what we have to do again, molar mass, everything. So, you know what we have to do? We have to apply the mole concept. Now, students, remember in atoms and molecules in this chapter, the main thing is just and just mole concept. Other things are theoretical. Mole concept, formula, unit mass, only these are very important. Apart from that, it's theory. Right? So, now, how will we do? We have sulfur trioxide. So, sulfur trioxide means SO3. Correct? SO3. Now, what is the relative molecular mass? First, we'll find the molecular mass. Correct? What will be the molecular mass? Molecular mass of SO3 will be S, which is 32, plus O is 16. So it is O3. So 3 into 16. Correct? Now what will we get here? We will do 16 into 3. That gives us 48, and 48 plus 32 gives us 80. So this is 80. Okay, 80 is the molecular mass. After that, molar mass, if I say molar mass, now molar mass will be what? Molar mass will be nothing but I will put just the unit. It will become 80 grams per mole, right? Just a unit I'll put. Now, how do I find out the mass of 1.12 moles of SO3? For SO3, 1.12 moles, how will I find it? Number of moles and molar mass. I have to take both of them. So, what is the number of moles we have? It is 1.12 multiplied by what is the molar mass of SO3? It is 80. So 1.12 into 80 gives us 89.6 gram, which becomes the mass of 1.12 moles of sulfur trioxide. And here is our answer. Now, next question. Give one example of a polyatomic cation and a polyatomic anion. Now, what we have to do is that we have to give any example of one polyatomic cation cation and also for an anion. Okay, so I'll just directly show you the answer. So for when I talk about polyatomic cation, it can be NH4, and remember it's cation, so put a plus sign above. This plus sign in cation is very important, because if you don't write that, your marks will be deducted. And similarly for anion, it is SO4 2 minus. Again, anion is there, so minus is important. Now, next question is, why does the atomic mass of an element not represent the actual mass of its atom? Now, this is again a critical thinking question, that atomic mass of an element, why does it not represent the actual mass of the atom? Now, when I say atomic mass is what? It is just okay, I'll just show the solution and explain from there. See, atomic mass of element, it doesn't represent the actual mass of an atom, because atomic mass is the average mass of all isotopes of an element, right? So how much ever mass of the isotopes is, we are going to take an average of that. Like for carbon, carbon 12, carbon 13, carbon 14. That's the average mass, is the atomic mass of an element, right? So the various isotopes we are going to take. Now, atomic mass of an element may be different from the mass of an atom of a particular isotope. Now, as I said, if I have carbon 12, 13 and 14, the average of them gives me the atomic mass, but each of them may have a slight difference between it. Okay, so this is, you can accept for 2 marker question. Yeah. Now let's move to the last subjective question, then we'll move towards case study. Now, 10 to the power 22, 10 to the power 22 atoms of an element X are found to have a mass of 930 mg. Calculate the molar mass of element X. Now, molar mass will be how much? It will be the mass of the Avogadro's number, correct? So the 10 to the power 22, 10 to the power 22 atoms will have how much mass? Okay, that we have to find. So molar mass we will find out. So first of all, we have this unit 930 mg. I have to convert it in grams now. So 930 mg If I divide it by 1000, so I'll get grams divided by 1000. Correct? 0 0 cancel, it will go, we'll get it as 0.930. Correct? That is the gram. So we got gram because we'll do the calculations in gram only. So this means that this much gram will be there in 6.022 into 10 to the power 23 atoms. Correct? Will have 0.930 gram weight. Correct? Not weight, I mean mass. That is what the Avogadro's number. Now after that, now what I'll do is I have to multiply. Now here when I say 0.930, this is my molar mass. Correct? Next I will divide that by my given number of atoms, it is 10 to the power 22. Then I'll multiply that by the Avogadro's number. 6.022 into 10 to the power 23, Avogadro's number. Correct? Now you can solve it, and after solving you will get it as 56.0. Okay, you can cancel out the 0. Yeah, 56 gram. Okay, now molar mass will be how much? Molar mass will be, so therefore molar mass, we have to find the molar mass, right? Yeah, so molar mass will be equals to how much? 56 gram per mole will be your answer. So here is your solution. Now let's move towards a case study based question on atoms and molecules. So in case study based question, what happens? You will have a case given to you, and based on that there will be questions asked. So let's see our case study. Lavoisier noted that compounds composed of two or more elements, and such compound had the same elements in same proportions, such as ammonia, nitrogen, and hydrogen, are always present in the ratio 14 is to 23 by mass. British chemist John Dalton provided the basic theory about the nature of matter. Dalton's atomic theory was an explanation for the law of conservation of mass and the definite proportions. Okay, there is some text misplaced, that's where. The postulates of Dalton's theory are all that matter is made up of very tiny particles which are known as atoms. Atoms are indivisible particles. Atoms of given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form a compound. So basically what they're explaining, your first part they're explaining about the Lavoisier thing. Lavoisier, Joseph Rowe, they made the law of constant proportions and law of definite proportion. Right? Now they are telling about ammonia. And ammonia, nitrogen and hydrogen are in the ratio 14 is to 23. That's the law of constant proportion. After that they're telling about Dalton, that he was a British chemist. He gave the six postulates of the atomic theory. Right? Now based on this, let's see what are questions. First one, define the law of constant proportions. What do we mean by constant? But now definition I'll show you. Okay, but for now understand what is constant proportion. I'm not giving a direct answer, I explain it. Law of constant proportion means that when we have that every element, all the element on this planet have elements, means they're combination of something. So they are the like the things in them, the atoms in them will have a specific ratio. For example, H2O, that's water. So hydrogen is to oxygen has a fixed ratio, that is 1 is to 8. Right? So it's in the ratio of 1 is to, that is the constant proportion. Now, if I say that I have 9 gram of water, so in that 1 gram will be hydrogen, 8 gram will be oxygen. And now, whatever the quantity of water is, this ratio remains constant. Similarly, that even given for ammonia, that was the nitrogen is to hydrogen is for 14 is to 23 ratio. Correct. So that is the law of definite constant proportion or definite proportion. So exact definition is, it's you can write that the law of constant or law of definite proportion states that in a pure chemical substance the elements are always present in definite proportions by mass. And you can even give an example either from the case study, or you can give for water. As I said, H2O, they are in the ratio of 1 is to 8. All right. Now, next question. Give an example to show law of conservation of mass applies to physical changes as well. Now, again in my video as well, I had shown an experiment, correct, which I had shown, I guess in your textbook as well this experiment is there for law of conservation of mass. It is on page number, yes, it's on page number, the first page, it is 31, page number 31. It's there, the activity where there are two different liquids have taken, and there the law of conservation of mass is applied. So here let's see it. Law of conservation of mass states that mass can neither be created nor be destroyed in any chemical reaction. But this law applies to chemical changes also. For example, when ice is melting into water, the mass of ice and mass of water both will be the same. So that's why law of conservation of mass means that whatever the physical change be or chemical change be, there the mass will always remain the same. All right. Now, last question of atoms and molecules. How do you know the presence of atoms if they do not exist independently for most of the elements? Again, a practical thinking question, that how can we say that atoms are there? Because they do not exist independently for almost every element, right? Now, let me explain you with the solution. Atoms, they mostly do not exist in independent state, agree, but when they combine in some specific numbers in some constant proportions, correct, in constant proportions, when they combine, so what happens, they form molecules or ions, cations, anions, or various polyatomic molecules they can form. And after that we can feel and know about their presence. For example, we humans, take just an example, we humans are what, many millions and trillions of atoms joined together, correct. So atoms, they do not exist independently, but when they join, when small atoms join, so they make molecule, and when that molecule is made, compounds are made, then entire structure is made. For example, molecules of H2SO4 consist of two atoms of hydrogen plus one atom of sulfur plus four atoms of oxygen, correct. So that way you can give the examples as well for C12H22O11, glucose, everything. So I hope atoms and molecules are clear. Now let's move towards our next chapter, which is structure of atom. Again, we'll do subjective questions, then we'll move towards case study. First question. Atomic number is defined in terms of protons and not in terms of electrons. Why? Now, this is a very common question. Again, application based, not a direct question. Atomic number, we use protons in them. Why not electrons? Now, when we say atom, in an atom we have studied that for a valency to be made, correct, okay, I'll change my pen color, yes. So for a valency to be made, to it be a valence electron, take suppose these are my electrons, okay, these are my electrons, this is my another element, okay, this is my another element, here and here. Now for making a valence shell, the for making my valence shell, what will I do, this will be combined. So when I talk about electrons, they can either be gained or they can either be loosed as well, correct, they can either lose or either we can gain it, correct. So that's why there are changes which occurs in electrons, it doesn't remain same. But when I talk about protons, protons are always they stay still, they stay and they remain as it is. They are, have you ever heard about the protons being exchanged? No, electrons are exchanged, okay. So that's why we use atomic number with the help of protons. Here is the solution. After that, why are anode rays also called as canal rays? Now, basically, more derivation part. Now, canal rays, anode rays, again experimental. We do like mostly you will get again structure of atom. Again, it's there in grade 11th also, where you're going to study in detail about the experiment J. Thomson, Bohr, Rutherford, right? So here, why we call anode rays as canal rays? Why both of them are same? Now, basically, there's not a very big explanation or something. Now, canal rays. When we studied about canal rays, what did we study in that experiment? Canal rays were the positively charged anode rays. Correct? They were nothing but the anode rays only, right? Positively charged anode rays, from the anode side they came. So that's why canal rays are also known as this thing, anode rays, because they pass through the holes or the canals from the anode. So that's why they're known as canal rays. So let's move towards the next question. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. Now, first thing, what was the name of his model? The model name was plum pudding model or watermelon model. Correct? Plum pudding model was his name. Correct? The model name. Now, what did he explain in there? That atom, this is an atom. Okay, the whole sphere is positive. The whole sphere is positive, whereas inside of the atom there are negative electrons. It's embedded. These are the negative electrons, they are embedded. That's what he said. Now, in his postulate, how do we get to know that atom is neutral? He said that atom is neutral because this is the sphere is positive, and inside of that sphere are these electrons which are negative. So positive negative makes what? Zero. So that's why he said that atom is electrically neutral only, but hence he was proven wrong. All right, sorry. Yeah, so he was proven wrong. Negative positive charges are equal in their magnitude, so electrically atom became neutral. Now, next question is, an oxide of element Z has a formula Z2O3. We have two questions over here, A and B. So A question is, how many electrons are there in the outermost shell of atom of element X? Outermost shell? Now in outermost shell, what will it be? Now if I say the ion of element Z, what will be the formula? So outermost shell, the ion of the element Z. If I say the ion of Z element, what will it be? It will be Z3 plus itself. Correct? Because it's Z2O3, right? Now if it is Z3 plus, so obviously the valence will be 3. There will be 3 valence electrons. Correct? There will be 3 valence electrons. Similarly, for the B1, write down the formula for chloride of Z. Okay, this is B. Chloride of Z. If I want the chloride of Z, chloride means Cl3. And for Z, I want to ZCl3 becomes the chloride. Here are the solution. Last subjective question. Atom of an element has 9 protons, 9 electrons and 10 neutrons. So based on that, we have 4 questions. Now, first thing, first question number 1 says, what is the atomic number of the element? Atomic number means the total number of protons, so it is 9. So first question is 9. Second, what is the mass number or the atomic mass? That is protons plus neutrons gives us the total thing. So that is how many neutrons are there? 10, and protons are 9. So 10 plus 9 is 19. So 19 is the mass number. Now for the third question, name the element and give its electronic configuration. Now here you cannot do any trick or something. You should remember which has 9 proton, 9 electron, 10 neutron. So that is nothing but fluorine. Okay, it is fluorine. Which element it is? It is fluorine. Now fluorine, and what its the electronic configuration is 2 comma 7. It is 2 comma 7. Okay, so 2 comma 7 is the configuration. Now Predict the valency. Now what will be the valency here? Now we have to find the valency. So what will be the valency of the element? Means for fluorine, what will be the valency? Okay, now fluorine, when I say fluorine, the valency is 1. Why 1? Because octet comes here. Because in the last shell, in the L shell, there are 7 electrons. So 8 minus 7 we have to do for forming an octet, that is 1. So 1 is the valency of the element. Now let's move towards the last case study. So the case study is the maximum number of electrons which are permitted to be assigned to an energy shell of an atom is called the electron capacity of that shell. The distribution of electrons in different orbits or shell is governed by a scheme known as the Bohrberry scheme. Okay, that's the Bohrberry scheme, and there are two postulates to remember for now, that are the maximum number of electrons that can be present in any shell is given by the formula 2n square. It's not 2n2, 2n square, where n is the number of energy shell. So K, L, M and shells, we find it by this formula only, right? 2 into 3 square for M shell, that way. And the maximum number of electrons that can be accommodated in the outermost shell is 8. Electrons are filled in the shells in a stepwise manner, increasing order. So first we fill the K shell, then we move towards the L, then M, and then if required to the N shell. Now based on that, let's do the questions. Electronic configuration of a neutral atom X is 2, 8, 6. What is the electronic configuration of X2 minus? Now we know that the electron configuration of X is what? 2, 8, 6. Correct. So how many electrons are there in the neutral atom? So in this neutral atom, number of electrons will be what? Number of electrons will be addition of all of them. 2 plus 8 plus 6. Because electronic configuration means the number of atoms. So that is 16. Now, X plus 2 times of electrons will give me x2 minus, right? So number of electrons in x2 minus will be how much? That will be 16 plus 2, because it's double, that is 18. So the electronic configuration of x2 minus will be 2 comma 8 and one more 8. So this becomes our answer. Now, so here is your solution, and after that we have, what is valence shell? How many electrons can be present in valence shell? Now, valence shell means what? Valence shell is nothing but the outer shell, the outermost shell with which we find out the valency. Correct. And the number of electrons that can be present in the valence shell is any number from 1 to 8. Okay, this is the answer. And next question, what are octet and duplet rules? How do elements maintain or attain an octet? Now, octet, duplet. Okay, first one is octet. Octet means that the atom, okay, let me show you the solution and explain you. Now, octet rule, it was proposed by G.N. Lewis, Gilbert Newton Lewis, right? So, according to this rule, what happens is the atom of an element combines with another atom to have 8 electrons in the outermost shell. So, in the outermost shell, if the atom by combining with another atom, it makes 8 electrons in total in the last shell. So we say that that element has obtained an octet. So that time we say that the element has obtained an octet. An atom having 8 electrons in the outermost shell is very, very less reactive or very stable. We can say it's very less reactive or very stable. Okay, so that is an octet rule. Now what about duplet? Duplet rule means that according to the duplet rule, if there is only one shell, then the stability is attained by having 2 electrons in the shell, and this is the duplet rule. Now there should be like in if the element has only one shell, and in that one shell stability is get by attaining two electrons, so that is the duplet rule. How can it attain a duplet? By losing or gaining electrons, or by sharing electrons by other elements. So that will be the duplet rule. Duplet, two electrons; octet, eight electrons. And the last question is, write the distribution of electrons in carbon and sodium atom. Again, I'll explain you the solution quickly. So, atomic number of carbon is 6. So, for hence, the first shell, the K shell, is going to have 2 electrons in it, correct? And now, see, the atomic number in total, the atomic number is 6. Correct, is 6. So, first will fill the K shell. K shell, how much will be there? 2 electrons. After that, how many are remaining? 4. So, 4. This is the electronic configuration. And then the present in the second shell, that is the L shell. So thus the distribution of K L shell will be 2 comma 4. That is the distribution of electrons, or indirectly they are just asking the configuration, electronic configuration. But remember, in your exam, don't just write 2 comma 4. That's it. And for sodium, no, write it step by step. And for similarly for sodium, atomic number atomic number sorry, not mass, atomic number is 11. So first 2 is filled. L shell, how much will can fill? 8, 2n square, 2 into 2 whole square, 8 we can fill, correct? And remaining is 1, so 1 in the M shell. So KLM 2 comma 8 comma 1. Alright, so thank you students for watching today's video. I hope we have solved many questions and it will help you for your doing your revision or practicing, or like you for studying atoms and molecules and structure of atom. And if you enjoyed this video, don't forget to hit the like button, the bell icon, so that you get regular notifications. Don't forget to like, share and subscribe, and comment down if you have any queries. I'll be seeing you in the next video. Till then, take care and goodbye.